Alright guys, welcome to 1.3 algebraic expressions. Our essential question today, how do you evaluate and simplify algebraic expressions? This should be a review for you. There's no new things in this section. So we're going to get started with a little warm-up question here. What is the difference between an expression and an equation? So pause it and think about it for a second. The difference is that an expression does not have an equal sign, so it's not equal to anything. So it's just, for example, x squared plus 9. That's an expression. An equation is x squared plus 9 equals 63, or whatever it is. Okay, so that's the difference between an expression and an equation. An equation has an equal sign. It's equal to something. All right, so what does an expression look like? Again, there's no equal sign, right? So this 5 out in front, we call that the coefficient because it's the number that's in front of a variable, and that would be this, the variable. It could be x, could be y. Please don't use e, please don't use I. Those are the two main ones we don't use for variables because they mean something else. Terms, these are each term. So the 5x is a term, the -3 is a term. And then the -3 is a constant. Remember to include the negative sign. All right, here we have some keywords that you're going to look for when we come across word problems. Math is just a language, and if you use the language, you can translate it from English into math. Just like you would English into Spanish or any other language, you can translate it into math. So we're going to organize these words based off of what operation they fall under. So difference would fall under subtraction. Double or triple or quadruple or quintuple or whatever, that would probably fall under multiplication. Plus, obviously, that's addition. Percent, that would be under actually division. All together, addition, because you're like adding them all together. Take away would be subtraction, so I'm kind of jumping around here. And would be addition. So if you have, usually it's like the sum of, 2 and 4 get added together. It's usually included in that type of sentence. And along those lines, together would be addition. Times, that's an easy one, that's multiplication. Product, that's the result of multiplication, so that means that it needs to be multiplication. Each, if you spend $5 and they were 40 cents each, you're going to be dividing. Sum is addition. Total would also be addition. Decrease, subtraction. Combine would be addition. Factors, when you factor something, you're thinking what two things multiply together to get that. Less than would be subtraction. If it's 3 less than a number, that would be, that number minus 3. Minus, obviously, is subtraction. Fewer would also be subtraction. Of means multiply. Whenever you see of, it's multiply. Quotient, that's what you get when you divide two numbers. Out of, also a division word. 3 out of 4 would be 3 divided by 4. And per, you think of miles per hour, that's miles divided by hours. All right, so these are keywords that, as we're going through word problems, whenever you see them, refer back to this chart, and you can literally replace that word with addition or subtraction or the symbol that applies. All right, so which algebraic expression models the word phrase 1 less than the product of 6 and w? Okay, so right away we see product of 6 and w, so we're thinking times here. And then we see the word less than, 1 less than, so that would be subtraction. Okay, now 1 less than the product. So let's just think of it, in terms of this problem, 1 less than 3. Well, what number is 1 less than 3? That would be 2, right? The common mistake is that people go 1 less than 3, but that's not right. It would be 1 less than 3 would end up actually being 3 minus 1 because we know that that equals 2, right? So I use that example for this problem because we have a product of 6 and w, so it would be 6 times w, right? We're using multiplication. And then 1 less than that, okay? The common mistake would be to do 1 less than, right? But that's not what we want because we need to subtract 1 at the end here. So 6 times w minus 1, so we're looking at answer C. All right, in an algebraic expression that models each word or phrase for more than a number b. Well, more than tells you to add, right? So for more than b. Okay. You could also do b plus 4. Addition you can do in either order. All right, the product of 8 and the sum of a number x and 3. Okay, keyword here, product of, right, multiplication. And then we have sum, which would be addition. Okay, so the product of 8 times the sum of x and 3. Now, order of operations is really important here, right? We're missing something very important. If we leave it like this, it's the product of 8 and x and then 3 more. But we need to do this first before we multiply by 8. Okay, the next one, the quotient of the difference between 5 and a number n and 2. Okay, the quotient, that would be division, of the difference, subtraction, between 5 and a number n and 2. Okay, so what this is saying is the difference thing is applying to 5 and a number n. The quotient is referring to this piece dividing this piece, okay? All right, so sorry for the pause, guys. So what we're going to do then is we're going to do the difference of 5 and a number, so 5 minus n. Okay, and that quantity, we need to do the quotient, right? So we need to divide by 2. So 5 minus n divided by 2. If you have parentheses around here, that's fine. As long as you have the bar over everything, you probably don't need them, but parentheses never hurt. All right. So now we have a bicycle trip here. You traveled 52 miles the first day, and then since then your average rate has been 12 miles per hour. Okay, what algebraic expression models the distance you traveled so far? So we're looking at 12 miles per hour. Okay, so 12 miles for every hour, right? Now, usually per, we're talking, what are we talking? That would be division, right? So 12 miles divided by 1 hour, right? 12 miles for every hour. Now, that's where the division kicks in. But then we're gonna be multiplying it by however many hours we're biking, right? And so if if we biked for 2 hours, we're gonna go 24 miles, right? So we're gonna go 12 times however many hours we traveled. Okay, and actually I should probably write this down in the equation here. Oops. Okay. So we did 12 miles per hour. For every hour we're biking, we go 12 miles, right? So that's multiplication. And then we've already gone 52 miles, right? So plus 52, that'll get us our total distance. So for example, if we wanted to go see how far we'd gone after 4 hours, we could just plug in 4 here, do 4 times 12 plus 52, and that gets us our total distance. Okay, as we're evaluating and working with expressions, it's important to remember our order of operations. PEMDAS, please excuse my dear Aunt Sally, is how I remember it. This stands for parentheses. I'm just going to do the mathematical symbol for it. Parentheses, exponents, so for example x squared, multiplication, division, addition, and subtraction. Okay, this comes first, this comes second, these two together come third. And how do you know which one to do first? You do just left to right, how we read left to right. Addition and subtraction is the same exact way. We're doing it left to right. So it's very important to remember that. It trips up a lot of kids. If you just remember order of operations, it solves a lot of problems. All right, so the given value of the expression for the given variables, and we need to plug in r, or 3 for r, and -9 for s. So first one, we're going to do 2 times 3 plus 5 times the quantity, -9 plus 6. Okay, and now we can just evaluate it here. First off, we need to do the parentheses, right, in our order of operations. So 2 times 3. Now, once you get proficient with this, you can just, you know that you can do this. But for right now, we're going to do it in order. The parentheses are, let's see, -9 plus 6. That would be -3. Okay, and now we don't have any exponents, so now we go to multiplication and division. 2 times 3 is 6. 5 times -3 is -15. Okay, and then we do addition and subtraction. And really, this is just 6 minus 15, right? And so we get an answer of -9. Okay, I'm going to try to finish up here in the brief time we have left here. Ticket prices for admission to a museum are $8 for adults, $5 for kids, and $6 for seniors, an algebraic expression that models it. So $8 for every adult. So if there was 2 adults, you'd get $16, right? And then if they had some children, we're going to add that on. You know, $5 for every child. And then if there was any seniors, you'd get $6 for every elderly person that comes through the door. So this would be our algebraic expression. And then we would plug in the appropriate numbers for adults, children, and seniors. Okay, if 20 adult tickets, 16 children's tickets, and 10 senior tickets were sold in one morning, how much money would be collected? Well, we would just plug in the numbers. So 8 times 20, because there was 20 adults, plus 5 times 16, plus 6 times 10. Okay, when we go to multiply this, that's 160. 5 times 16 is 80. And then 60. When we add it all together, we get $300 was collected in tickets. All right. Some vocab here. Terms. These are all terms. 2x is a term. 3x squared is a term. -5y is a term. X squared is a term. They're all terms. Okay. The coefficients are the numbers in front of the variables, right? The -7 is also a term. So our coefficients would be 2, 3, -5, technically 1 right here. Now, the -7 is not a coefficient because it's a constant. Okay, and lastly, like terms. The like terms have the same power, and so in our case, it'd be the 3x squared and the x squared. Okay, last one. Let's see if we can fit it in real quick. We need to combine like terms here, right? So 2a squared and 5a squared, we can combine that into 7a squared. And also 3b squared plus 6b squared is 9b squared. Treat these just like apples or bananas, you know, it'll